This is the prerequisite review for section 4.3, logarithmic functions. We have 3 objectives on this worksheet, and we will begin with objective number 1, converting between rational exponents and radical notation. So we're going to be going back and forth. So here we want to convert to radical form, and then we will simplify. So as you can see, we have power over root, okay? So 2 is the power and 3 is the root. So we actually have the cube root of 8 squared. And so now we have the cube root of 64, and we know that that is 4. So using radical notation helps us compute these expressions. Again, power over root. So we have the square root of 100 to the 5th power. So we have the square root of 100 to the 5th power. If you go ahead and either put that in the calculator or whatever you might want to do, we would end up with 1 times 10 to the 10th power. And you can go ahead and put that in your calculator and then see that the square root would be 100,000. And basically what you have here is 2 zeros 5 times. So we would actually then, when we take the square root, we would only have 5 zeros. Okay, looking at number 3, we have the square root of 144, and we know that that is equal to 12. In number 4, we have power over root, the square root of 25 cubed. Now, there's something else that we can do here. Instead of cubing 25, we could also take the square root of 25 and cube it. So we are able to take power over root and whatever order we would like to do that in. So I like this second one because the square root of 25 is 5, and then we cube 5 to reach 125. We could go back and look at number 2 in the same manner. We could say, whoops, let's keep that first thing we wrote. Or what could we say? Or we could say we want the square root of 100, and then we want to raise it to the 5th power. So that's another or, and actually we like that one. That's a better one. That is 10 to the 5th power, and that's how we arrive at the answer we had earlier, which was 100,000. So that's a 1 with 5 zeros. So we can choose what order we would like. Looking at number 5, we have power over root. So again, we could go ahead and take the 4th root of 16 cubed, or we could take the 4th root of 16, and once we find that answer, cube it. And this is the one we like. And so the 4th root of 16 is 2, and 2 cubed is 8. Okay, let's do the same thing here. Let's go ahead and decide to make the number smaller first, if you can, using the root, and then use the exponent. So sometimes that's a good way to state that. So let's do that. Let's take, and this is the opposite of 16 to the 3/4 power. So it does not have that. Okay, so it's really important to know that we're going to put a negative on our answer. Okay, so now what we're going to do is we're going to have the 4th root of 16 and cube it. And again, we have the opposite of 2 cubed, and then we have -8. Let's see if I can move this away from this problem just a little bit. Whoops. Just wanted to move it maybe about right here. Okay, let's go look at number 7. Now, what do you notice here? This negative is on the inside. So we actually have the 4th root of a negative number, and then we're going to cube it. But this is not a real number. We cannot, that's an imaginary number when we have a negative number under an even root. So let's write that out. A negative number under an even root. Okay, let's go on to number 8. So we go ahead and have the square root of 4, and then we're going to cube it again, power over root. So we have 2 cubed and we have 8. Here you notice that we have a negative power. We want to take care of that first and go to the denominator with the positive exponents. So use positive exponents. Now, 1 over the square root of 4 cubed, we have 1 over 2 cubed, and we have 1/8. Okay, and looking at number 10, you can see that we have the cube root, whoops, the cube root, so power over root. So the power is 1, but the root is 3, and the cube root of -8 is -2. Looking at number 11, again, let's move that to the denominator, that expression to the denominator, so that we can remove that negative in front of the exponent. And now we have 1 over the square root of 25, and that is 1/5. Looking at number 12, 1 over 64 to the 3/2 power. That's again because we have that negative. We have the square root of 64, and once we find that, we're going to cube it. And the square root of 64 is 8, and 8 cubed is 512. So if we take these one step at a time, we are able to compute these expressions, simplify these expressions. Okay, so that is actually objective 1 and 2. And now, and those were the properties, and we learned those properties of rational exponents, the negative, sending it the expression to the denominator to make that expression positive. Now we're going to solve polynomial inequalities, and these are really important, and we learned how to make sign charts and take care of these. So we're going to go ahead and use our boundary points, and we have to solve t minus 7, t minus 1 is equal to 0. We have t equals 7 and 1. So we use those as our boundary points, 1 and 7. Let me erase that real quick, come over a little bit more. And we will use our dashed lines. And then we will write test and find values. We'll put an 8 there. How about a 5 here? And we love to use our 0 when we can. We will write our factors, t minus 7, t minus 1. We will go ahead and plug 0 into both of those, 5 into both of those, and 8 into both of those factors. Positive, negative, positive. Now, we have here less than. So we're looking for negative, and that is right here. So that interval, because that is just less than, we will have 1 to 7. So this answer would be 1 to 7. Every x value between 1 and 7, but not including 1 and 7. And you know what? I could actually put this down here, and that would be our answer. Looking at number 14, we have some factoring to do. So we have two numbers that we're looking for that multiply together to give us 64, and add together to give us 20. And you can take some time and think about that, but it would be a 16 and a 4. So we will divide both of those by a W, and we have W plus 16, and W plus 4 is greater than or equal to 0. Let's go ahead and make our sign chart. And this time we have a negative 4. Oops, let me move that over because that's where I do my testing. And we need a negative 16 before that. As long as they're in the correct order, that's all that matters. As you can see there, we used 1 and 7. Okay, so now we will write test, and we will pick some values. We like 0 here, maybe negative 10 here, and maybe negative 20 here. We will write our factors, W plus 16, W plus 4. And plugging negative 20 into both those, we will have a negative and a negative. We will have a positive and a negative. And plugging 0, we will have a positive and a positive. So creating our chart, we now see we wanted greater than or equal. So we're looking for positives, and they are right here, these intervals. So we would have all values that are greater than or equal to negative 4, less than or equal to negative 16. So that solution is negative infinity to negative 16, and we need a bracket, union with negative 4 to infinity. Okay, moving on to number 15, We do not have factored form, so we need factored form and 0 on the right-hand side. So as you can see, we have x squared plus x minus 6 is less than or equal to 0. We have an x plus 3 and an x minus 2. And how we get that is two numbers multiplied together to equal -6. But when you add them together, we have a positive 1. So we would want 3 and a -2. And we have x plus 3 multiplied by x minus 2. We go right into our sign chart with our boundary values of a -3 and a positive 2. And we have test, and we have maybe -5. We want to use that 0, and let's go with a positive 5. You can use any number larger than 2. We have x plus 3, x minus 2. Filling in our chart, plugging in a -5, plugging in a 0, and plugging in a positive 5. And here, as you can see, we are looking for negatives. And we also want to include our boundary values. So here, we would want -3, everything larger, and also to include a positive 2. So that solution is -3 to positive 2. Okay, looking at number 16, as you can see, we have a difference of squares, so c plus 5 multiplied by c minus 5 is less than 0. So we have our boundary points right away as -5 and positive 5. And we will create our chart again. Here we have a less than 0, so we are looking for negative. And that is the interval, and we do not want to include the endpoints from -5 to positive 5. So our solution is -5 to positive 5, and we do not want to include those endpoints. And that concludes this worksheet.